they told me. All right, guys. So what you have here are the rules about f prime, and f double prime. So notice, it's everything's in here. If f prime, look at number two. If f prime is positive, if f of x is increasing, it shouldn't say if. It should say f prime is positive, f of x is increasing. If f prime is negative, f of x is decreasing. All of them are here. A relative max occurs at an x value of f of x, where f prime goes from positive to negative. Make sure okay, you can be a robot, but try really hard to understand why these rules exist. Can you trick me into thinking that you know this stone cold? Yes, but you can trick me by being a robot. Like, oh, if f prime is positive, f is concave up. Like, you can trick. Look, there it is. You just tricked me. Congrats. But don't do that. Like, make sure you understand why. Cool? Okay. I hope that you guys like this. I didn't create this. If I would have created it, I would have probably deleted the if word. If f prime of x is positive, f of x is increasing, period. So I took this from someone. I don't know who that someone is. So shout out to whoever created it initially. Maybe Mark, maybe Verge. I don't know. All right. There's a whole bunch of examples here. We've already done examples. I want to go right into, so keep going all the way. If you want to do those, let me know. I want to do these. I think these will give us the most bang for our buck. Plus, they'll start getting us ready with curves. All right. Before we start, there's only 4 types of curves. So you don't have to memorize a whole bunch. You're either increasing concave up. So let me write the 4 types of curves we have. Increasing concave up, increasing concave down, decreasing concave up, decreasing concave down. That's it. Yay or nay? Okay. Look at number 1. The very first thing you're going to do, it says, let f of x be continuous function such that f of 2 equals negative 1. Sketch a possible graph for f of x given the information about f prime and f double prime in each table. First thing you're going to do, always and always and always, plot this point for all of them. So go to 2, negative 1. 2, negative 1, point. Did everyone plot that point? Okay. This is f. You guys ready? For x less than 2, it says that f prime is positive and f double prime is negative. So if f prime is positive, tell me what's happening to f. Increasing. What does it mean for f double prime to be negative? What's happening to f? Concave down. So draw an increasing concave down leading up to that point. Increasing concave down leading up to that point. Notice right at 2 that the derivative is 0, so I should have a horizontal tangent, and I do. Immediately greater than 2, it says f prime is negative and f double prime is negative. So if f prime is negative, what's happening to f? Decreasing and concave down because of the second derivative. Perfect. You guys are funny. So I have a parabola opening downwards, and there it is. Does that make sense? Okay. Is this helping? Okay, first thing I'm going to do, plot the point. What point am I plotting? 2, negative 1. Call that f. Well, call this whole function f. All right, to the left of that point, f prime is positive and f double prime is negative. So I am increasing what concavity? Concave down. So the same as the before, increasing concave down, 0, right, a horizontal tangent right at 2. And now look, now greater than 2, it's positive, positive. F positive for f prime, positive for f double prime. Increasing concave down. Sorry, concave up. Concave up. There it is. Yes.
What does it mean when the concavity is 0?
It's when the second derivative is 0, it's a possible point of inflection. Not always. It's a possible point of inflection. Not always, though. Child, can you give me an example where that doesn't happen? X to the 4th. We have it in our notes. If we took this derivative twice, notice you have a 0 at 0. But x to the 4th looks like x squared. It never changes concavity, even though the second derivative is 0 at 0. Okay. How do we feel right now? Okay, let's go to the next one. It's still the same type of question. You're still plotting f of 2 equals negative 1 because it's the same for all of these. So go to 2, negative 1, point. We're going to call this f. You guys ready? Yeah. F prime is negative. F double prime is negative. So f prime negative means I am decreasing. And second derivative negative means I am concave down. Notice that it's undefined, so that means I'm going to have like a corner or a cusp or something. So it's probably something like this. Decreasing, concave down. Decreasing, concave down. Bam. When I'm greater than that point, all of a sudden both of them are now positive. So that means I am increasing, concave up. Yeah, it creates like a corner. You guys see that? How do we feel? Okay, let's go to the next. Still, same point. Plot f of 2 equals negative 1. This is still f. To negative 1 point. To the left of 2, both of them are positive. So that means f is increasing. What's a concavity? Concave up. So let's do an increasing, concave up. Increasing, concave up. To the right of 2, the derivative is negative, second derivative is positive. So I am decreasing, concave up. It looks like a bird. Well, let me not put the arrowhead so it looks like a bird. That's how I used to draw my birds in elementary. So I still do, actually. What am I talking about? That's a bird. I got a D in art. Did I ever tell you guys that? I'm not proud of it, but I'm okay with it now. Don't worry, this will only take 30 seconds. I got a D in art, and it's the very first line on my transcript. The very first line. So that's why when someone asks for my transcript, I'm like, oh, don't look at the first page, please. That's the only D. I don't even have C's. I graduated cum laude, but I have a D in art. D. D as in dog.
Wait, DNR as in like, what does that mean?
That means bad.
A D in the great in art. I heard do not resuscitate. Like,
Yeah,
that's what I thought. And so I was like,
that's so sad.
Maybe. Yeah. No, D and R do not resuscitate. Miss, I feel like sometimes this is why we have a disconnect. Like the math, like, what? No, I didn't say that at all. I'm like, no, you said it. Like, right now you just heard do not resuscitate when I said D and art, not.
well, DNR, do not resuscitate
Okay.
is the acronym for DNR.
Yeah, it's not DNR. I got a D in art. Miss, transcript. Okay. I'll see if I can delete that from this video, or maybe I'll leave it. I don't know. All right, here we go. Plot the point. This is F. Plot the point 2, negative 1. There it is. Can you see the grid in your paper? Because I don't know if you. Okay. The derivative is negative, and the second derivative is positive. So what does that mean? Decreasing, concave up. Notice my derivative is 0 at 2, so I'm going to have a horizontal tangent. So decreasing, concave up. Here it is. Decreasing, concave up. Boop. Horizontal tangent right at 2. Then for x greater than 2, they're both positive. So what does that mean? Concave up, increasing. It's a parabola opening upwards now. Do you guys see that? Okay. All right, there it is. Do you think we're ready to do a free response question? No? Let's do this one, because this one is f prime. So go to the graphical representation of derivative information. It says f of 1 equals negative 1. So the first thing I'm going to do is what? Plot 1, negative 1, point. And the graph of the derivative f of x, that is f prime, given below. What do we know about f of x? Catch a possible graph. You guys ready? To the left of to the left of 1, notice to the left of 1, the derivative is, well, yeah, but positive or negative? Negative. So the derivative is negative, and the derivative is increasing, just like you said right now, right? So the derivative is negative. That means that f is decreasing, and f prime is increasing. So that means f is concave up. You got it. So you got it down. So draw a decreasing concave up, leading up to 1, negative 1, and right at 1, negative 1, I have a horizontal tangent because there's a 0 in f prime. Don't worry, I'm going to say all that again because there was a lot of information. You guys ready? I'll say it again. To the left of 1, notice f prime is negative. So if f prime is negative, that means f is decreasing. So let's write that down. So I'm going to write f prime negative means f is decreasing. So maybe putting it in words helps. Does that help? Okay. Now, what do you notice about f prime? It's f prime is what? F prime is increasing on, let me go ahead and put the interval on bracket 0, comma to 1 on the f prime graph. Talking about f prime graph. Comma. So what does that mean? That means that f prime prime is positive on 0. Not about the greater than or equal to 0. On 0 to 1. There we go. Does that make sense to you guys or no? I'll go slower if I have to. F prime is increasing. This is f prime. It's increasing on the f prime graph. So what does that mean in terms of f prime prime? That f prime prime is positive. And if f prime prime is positive, what does that mean about f? Concave up. Do we see that?
Oh, we talked about this.
Yeah. So this is why that delta math one is so hard, because they keep throwing you all these different curves, all these, and then you're like, oh, what? And then, yeah, you just got to slow down. Yeah, slow down for the delta math because it's going to be tricky.
Function of f itself, say it's either the concavity, and then f prime it's increasing or decreasing, and then f prime prime is positive or negative.
So like the first interval you have 0 to 1,
Mhm.
it's increasing.
F prime is increasing.
F prime is increasing, and since it's concave up, then
F is concave up.
Because it's increasing, we know it's f is concave up.
Yeah, because f prime is increasing, that means that f prime prime is positive. Because f prime prime is positive, I know that f is concave up.
so what did you say about it being negative earlier?
F prime is negative, so I know f is decreasing. There's a lot. This is why I'm being very specific. If f prime is negative, f prime is the slopes of f. Then f has to decrease because it's the slopes of f. If the slope is negative, that's a decreasing curve.
And it's concave up
Because my slopes are increasing. Do you know what that means when I say slopes are increasing?
but it's. Can you just explain?
Yes. Look, let me draw something that's strictly concave up so you can see. So you see this concave up, strictly concave up? Look, I'm going to put slopes. I'm going to put the values of the slopes. F prime equals negative 10. F prime equals negative 5. And I'm going to say this is F prime equals 0, right? Look, F prime equals 5. F prime equals 10. Cool or not cool? Look what's happening. And don't worry, I'm gonna do even better, miss. I'm gonna do even better because I want to be the Michael Jordan of math teachers. I'm gonna draw a curve right now for this. Notice, look what's happening to F prime. Negative 10, negative 5. If you were to graph left to right. 0, 5, 10. If I were to plot those points on the same grid, so here's my grid. If I were to plot those points, this is my x-axis. Look, I'm trying to plot the same. This is a negative 10. There's anything below that line is a negative, so negative 10, negative 5. This one, the next one, negative 5. This one's at 0, 0, 5, 10. Oh, look at that. And I call this my f prime graph. Look, my f prime is increasing. Do you see that?
How does that go is on the negative, like when f prime is negative?
If f prime is negative, f is decreasing. Because it's the slopes. It's the slope of f. No, check it out. Maybe it will mind blow you. Maybe you'll already know this. Notice that this is kind of like a parabola. What's the derivative of x squared? Which is linear, right? OMG, look. My derivative of that parabola is a linear line there.
No, I can look for the same though, because I remember we did it 1 and 2, and it was like if it's under the x-axis.
Yes. That's if it's under the x-axis, it's negative. If it's above the x-axis, it's positive. I'm under the x-axis, it's the slopes are negative.
So the slopes are negative, and
But
then it's increasing.
yes.
concave up.
Yep. The slopes are negative, but the slopes are also increasing.
I was just confused on how it like transfers.
Yeah, like that.
So f prime prime is negative.
No, f prime is positive because the slopes are increasing. The slopes are increasing. You just said it.
We just said it was negative.
F prime is negative.
So it's negative, but it's increasing.
This is, yeah. Look, this part is negative.
How is not that easy?
Miss.
Just look.
Look, is this not going up left to right?
Well,
Is this not going up left to right? But what is this? What is this? F prime is increasing. It's just a name. This is F prime. F prime is increasing. If F prime is increasing, F must be concave up because F prime prime is positive. Hold on a little bit. Let me just do this graph here. You see what I mean? But now look, this graph, this is F prime. This is the slopes of F. It's negative. Yeah, don't get tongue twisted, guys. Go slow. This is F prime. If I'm below the x-axis, F is going down because these are slopes of F. Right? But now look, what's happening to my slopes? My slopes are increasing, just like we showed right now, that the slopes are increasing. The slopes are increasing, so that's what creates concave up for F. Say it again.
Looking at the y values.
Of the original, they're
Yeah.
that creates my concavity. That creates concave up. So there it is. So here it is. We just did so good right now with these guys. It's the same. It's the same. Yeah, now the thing that's throwing you guys off is now instead of writing it in words, they're putting it in a graph here. All right, here we go. You guys ready? So to the left of 1, I am decreasing F. F is decreasing concave up until you hit this. So here it is. Decreasing concave up. Yay or nay? Okay. Now to the right of 1, let me put it in blue, so I'll color code it. To the right of 1, F is increasing and concave up. Do you guys see what we're doing there?
So because it changes signs, that's why.
Well, I guess if I want it to be 100% correct, I should be drawing it like this. Only because see how it starts here? So it doesn't matter where I start. And then so that one ends like before 2.
Are both of them increasing in the slope of
F prime is increasing from 0 to 2, yeah. So it's always going to be concave up. F is always going to be concave up. Right? So we're going to do another one.
So it's going negative to positive. Is that why there's a?
It doesn't matter. I could have, well, it does matter, but I don't know my steepness. I do know this part.
No, I'm asking.
Oh, it's about the, okay, go ahead.
I just meant the minimum.
The derivative is going from negative to positive, so I have a minimum, yes.
Like I was asking, is that why?
Yeah. Because my derivative is going from negative to positive at 1, so I have a minimum at 1. All right, check this out. Okay, this is just words. We'll stop with this one. This will be the last one. I'll see if I should have. Okay, f of 2 equals 3. Okay, the graph of the derivative of f of x. So this graph is f prime. Determine the intervals where f of x is increasing and or decreasing. Okay, I'm increasing from. I'm gonna put arrowheads on this. I'm increasing from -1 to what? Yeah, increasing. F, right? F is increasing. Is increasing on the interval -1 to 2 since f prime is greater than or equal to 0 on this specific interval. Yes. When you're increasing and decreasing, you use brackets, and if it's concavity, you use parentheses. I didn't want to write another statement, so I just put the greater than or equal to. You could have just said f prime is greater than 0 between -1 and 2, but if you do that, you got to put parentheses. Are we still okay, guys? Oh, we haven't answered the other one, right? Where am I decreasing? F is decreasing on -infinity all the way to -1. That's a 1. It just came out ugly. 1 bracket and bracket 2 to infinity since f prime is less than or equal to 0 on this interval. I put the equal sign, that way I don't have to rewrite anything. So we don't say anything wrong. We're still okay? All right. Don't worry, I'm gonna slow down. Ms. Cruz, you're doing okay? Esquivel, you doing all right? Determine the intervals where f of x is concave up or concave down. Where am I concave up? Where okay, you're right, but be specific because yes, guys, I can't stress enough how many times students have lost points because they just say where it is increasing. You gotta be specific. There's been so many times where I'm like, man, I want to give you points, but I can't. You gotta state why. So f is concave up on from -infinity all the way to since, what graph do I have here, guys? So that's the one you want to reference. Since f prime is increasing on this specific interval.
Is there a bracket on half?
No, for concavity, never use brackets. All right, where am I concave down?
Half to
Half to
negative
infinity, right? F
Oh, yeah.
is concave down on parenthesis 1/2 comma to infinity, since f prime is decreasing on this specific interval. All right. Am I still okay? Sketch a graph. Chop, no. There is a delta where you have to sketch. You don't have to be perfect. You just got to have, you don't have to, you can be wildly unperfect as long as you'll see. We'll see if we have time. Maybe during lab, we'll do some samples. All right. Plot this point, 2, 3. So call this F and go 2, 3 point. All right, we're going to go in intervals. From negative infinity, let's go to -1 first. From negative infinity to -1, F is decreasing, and I have a horizontal tangent at -1. Man, they're making it hard for me because they didn't put where I'm going to be at. So decreasing, horizontal tangent, concave up. So I'm going to say decreasing, concave up. I'm going to say I'm right here. See? Decreasing, concave up. We're still okay, guys? From -1 to 1/2, I am increasing and concave what? No. Concave up because f prime is increasing.
Yeah, because from negative infinity to half.
Yeah. So from negative, so I'll even color code it, guys. So you guys can let me go ahead and color code it. I did that in red, so here it is in red. This part in red is that in red. So what color do I want me to use next? Purple. Okay, so this part in purple. Oh, that's not purple. This part in purple. There it is. That part in purple is this part that I'm about to put. F is increasing, and what's my concavity? Up. Increasing, and let's all the way to half. Okay, half is right smack there. So here it is, increasing, and bam, there it is, right there. Are we still okay? See, increasing, concave up. Now, okay, let me change colors. What color do you want me to use next? Orange. So there it is. Now I'm doing this part in orange. I'm doing this part in orange. Now I am, what is F doing? Increasing or decreasing? Still increasing, but what's the concavity now? Down. So increasing, concave, down until you hit 2. So until you hit 2. So increasing, concave, down. Oh, sorry. Increasing, concave, yeah, there it is. I should have made this a little steeper, but that's fine. Do you see how that's concave down? And increasing still? Right at 2 is a horizontal tangent. Yeah, I probably should have dragged this purple line more down there, but that's fine. All right. Next color, blue. Is that okay with you guys? Okay. Now I am decreasing, concave, down. All the way down. I'm going to stop there. And there it is. I color coded it and everything. How do we feel, guys? Okay. Yeah, ask me. It's all good. Yeah, we just need practice, guys. There's a lot more here for practice. What's up, Vega? Why what? They got to give you a y value, and we need to know like more detail. At the moment, we're not good enough, but we are good enough to plot a point and to make sure we go through that point. You know what I mean?